Hello engineer, welcome to introduction of water resource engineering. Today we are going to discuss about water resource engineering. This is the first video that I am going to present you. First, did you know that over 2 billion people in the world face water scarcity every year? Water is life, but managing it is not easy. Today we will explore water resource engineering, the backbone of how we plan, use and protect this vital resource. First, define water resource engineering. The simple definition is water resource engineering is the branch of engineering which deal with planning, developing, distribution, and management of water resources. Why it is matters: supports irrigation, hydropower, urban water supply, flood control, and environmental protection. For example, dams, canals, rainwater harvesting, and groundwater management. What is water resource engineering? Water resource engineering is a branch of civil engineering that deal with planning, development, and management of water. This includes rivers, lakes, groundwater, and even rainwater. Its goals to provide water for agriculture, cities, industries, and energy, while preventing floods and environmental damage. Importance of water resource engineering. Why is this so important? Because water is finite and unevenly distributed. Engineers helps ensure that every drop is used efficiently. For example, designing irrigation system that reduce water losses of dams that store floodwater and provide electricity. Types of water resources. There are three main types of water resources. First, surface water like river, lakes, reservoirs, easy to access but can dry up seasonally. The second, groundwater, stored in aquifer, reliable but slower to recharge. This is the crucial topic. Rainwater. The third one is rainwater, can be harvested and stored for later use. Good engineer who knows to combine all three sources efficiently. Components of water resource engineering. The field includes several important areas. First, hydrology, studying the movement and distribution of water, like study of water movement, distribution and availability. The second one is hydraulics, understanding how water flow in channel and pipes, like flow of water through rivers, canal and pipes. The third one is irrigation and drainage, delivering water efficiently to crop. In irrigation engineering, efficient use of water for agriculture. Water supply and sanitation, providing clean drinking water and handling wastewater. Like water supply and sanitation mean safe drinking water and wastewater management. This is the very important topic in sanitation. And the fifth one is flood control and reservoir engineering, designing structure to prevent disaster. Flood control and reservoir engineering, structure to prevent disasters. As you may know about hydrological cycle, everything starts with the hydrological cycle: precipitation, runoff, infiltration, groundwater, evaporation, and condensation. Understanding this cycle helps engineers predict water availability and design dams, reservoirs, and drainage system. Basic process shows movement of water in the environment: precipitation, runoff, infiltration, groundwater, evaporation, condensation. Importance: help engineer predict availability, plan storage, and manage floods. As you know, you can see everything in picture of water cycle. Water resources planning and management. Water resources planning is all about matching supply and demand. Engineers analyze how much water is available, how much is needed, and plan reservoirs, canal and pipeline accordingly. The goal is to use water efficiently and sustainability. Goal: optimize water use and ensure sustainable development. Tools: demand analysis, supply estimation, reservoir planning. For example, planning urban water supply in a growing city or allocating irrigation water efficiently. Challenge in water resource engineering. Water resource engineering is not without challenge. Overuse of groundwater and surface water, pollution and contamination, floods and drought due to climate change, sedimentation, reduce reservoir storage. Engineers design solution to overcome this challenge. Water scarcity, overuse, and population. Second, climate change causing floods and droughts, sedimentation in reservoir and groundwater, depletion, urbanization, increased demand. Engineers must design resilient, sustainable solution. Rules of engineers in water resources. Analyze water availability, design dams, canals, irrigation systems, implement sustainable practices like rainwater harvesting, help prevent flood and water storage. Means analyze water availability and demand calculation, design dams, canal irrigation systems, and stormwater networks. Implementation of design project sustainable practices needs like rainwater harvesting, groundwater recharge. To know all the basic about this and flood risk mitigation. Modern trends in water resource engineering. Modern water engineering use technology, smart irrigation systems with sensors, GIS and remote sensing for water mapping, flood modeling software, water reuse and desalination technology. In short, water resource engineering is essential for society, agriculture, cities, and the environment. Understanding it helps us manage water wisely and sustainably. If you want more video like this one civil engineering in water project, hit the subscribe button and follow for practical engineering knowledge. Thank you.